Welcome everyone to this video. We are going to discuss question 16 which came in JEE Advanced 2023 examination. So basically the question is for LCR circuit, and the of this question is particularly very interesting, which I want to focus on. We are given the voltage amplitude of the system, that is 45 sine omega t. This is the voltage source. The resonant frequency of this circuit is 10 to the power 5 radian per second. So let us begin from that. 10 to the power 5 is equal to 1 upon square root LC for a LCR circuit. We are given that the inductance of the inductor is so 10 to the power 5 is equal to 1 upon square root 50 into 10 to the power minus 3 into capacitance. So capacitance is what we can find. Using that, we have to find the current amplitude in the circuit. So current amplitude is 0.05 I naught when the angular frequency of the source is 8 into 10 to the power 4. So that means that K I naught into 0.05 is equal to the voltage supplied by the circuit, that is 45, divided by the square root of uh, the voltage, the resistance that is R. I think yes, the resistance would be some R square plus um, omega, that is 8 into 10 to the power 4 into 50 millihenry uh, minus 8 minus 1 upon 8 into 10 to the power 4 into capacitance square. So basically, from this equation, we can find the capacitance of the resistor. So we can say capacitance, that is square root C, is equal to 1 upon square root of 50 into 10 to the power minus 3 into 10 to the power minus 5. So C is equal to 10 to the power minus 10 divided by 50 into 10 to the power minus 3. So that is 10 to the power minus 7 divided by 50. So that is 2 into 10 to the power minus 9 farad. So this is 2 nanofarad, that is the capacitance. And um, the value of resistance we can find. Uh, we can say that K I naught is nothing but 45 divided by R naught. So if we substitute that value over here and the value of capacitance in the circuit here, so that is the two calculations which we have to look for. First calculation is we have to put I naught, first substitution I naught here, and the second substitution is the value of capacitance. So we'll be eliminating the value of R over here, right? Or maybe R will get, because we have eliminated I naught. So rather than eliminating I naught, you can eliminate R. You can write R as 45 by I naught. So you'll get the value of I naught as some uh, 0.4 amperes. This is the value of I naught we'll get after calculation, right? Uh, then we can match the option P with option Q, or with third option, right? Um, so thankfully, actually, that does the question for us. The option B is the only one in which P matches 3. But we can also do other parts of the question as well. That what is the quality factor of the circuit? So the quality factor of the circuit Q is given by some value. Since Q is some dimensionless value, it goes something like R upon square root L by C, something like that. This is the um, basically the function of Q, quality factor. So basically the expression is not as important as the fact that it shows you the sharpness of the resonance. The higher the value of Q, the better the resonance is. Then we have peak power dissipated. So peak power is dissipated at the resonance itself. So this value is some I square R. So note that this is independent of inductance and capacitance, since they are uh, not basically participating at peak power dissipation. So this peak power dissipation, this is going to come as 18 watts. So that's it for this question. Thank you for joining.